In this video, we are going to look at Unit 7, Lesson 10, Angles, Arcs, and Radii, and we are going to analyze relationships between arc lengths, radii, and central angles. By the end of this video, you will hopefully be able to compare the central angles of two circles when you are given information about the circle's arc length and radius measure. On page 210, you'll see these two diagrams, and they represent Tyler and Han's progress on their homework from a website. So Tyler is completing his on a tablet, and Han is completing his on a phone, and then we see these progress bars. So Tyler says that the arc length on his progress bar, so the actual length of this blue arc here, is equal to 4.75 centimeters, and the arc length on Han's progress bar is 2.25 centimeters. So Tyler says, so I've completed more tasks than Han has on this homework. Do you agree with Tyler? And what would you need to make an accurate comparison? So go ahead and think about that, and then come back to the video, and then we will discuss. All right, so when we're looking at these tablets, a couple of things here that we're looking at is we actually see two circles making up this bar, and then that kind of bar is in between them. So what do we need to focus on? Should we be looking at the inner circle? Should we be looking at the outer circle, or does it matter? So it didn't matter whether you're looking kind of on the interior or the exterior, it's going to give you the same information. And if the length on Tyler's circle is longer, okay, which he said it was 4.75 versus 2.25 on Han's, why does that not mean that Tyler has necessarily completed more tasks? And that has to do with the fact that the completion would be the portion of his arc length to the total circumference. And this circumference is going to be larger than this circumference on the phone. So it takes more than just knowing the length. You need to know the portion that's completed, or the fraction that's completed. So what would we need in order to more accurately compare the progress of the student's work? So we could certainly know the circumference and then divide to be able to look at the proportion or the percent. But speaking of like measurements within the circle, what we truly need is the central angle, because that central angle represents the fraction of 360. So both of these circles are 360 degrees total. So if we knew this this central angle measure, we could do a direct comparison there. So what angle or central angle is completed? And then when we're talking about the actual size of the circles, what's the measurement that we use to look at size of circles? And that's going to be the radius. So if we're looking at kind of portions of the arc and what percent of the circle is being covered, or what fraction is there, that would be central angle, or how far around we are. And then comparing the actual size of the circles has to do with its radius. All right, then page 211, we see this diagram. So we have two circles. The larger circle is a dilation by a scale factor of 3 from the smaller circle. So on page 211, you'll see each part, you'll see some parts listed out there. Determine the factor by which that part is changed when compared to the original. Based on that, we know that it's a dilation of a scale factor of 3, and remembering what you know about dilations. Once you've done 1 through 5, then come back to the video and we'll discuss it. All right, so here are the 5 things that we were looking at in comparing these two dilated circles. And so if we kind of remember back to when we were talking about dilation, we often called the scale factor the K value. So when we were comparing areas with scale factor, remember that the area factor was actually K squared. So how much is the area going to be impacted compared to the original? So that's going to be 9 times bigger because we're going to have the K value squared. So we're going to need to take this 3 and then square it to say what's going to happen to our area. So it's going to be 9 times bigger. How about the central angle? And you can see the central angle labeled in this one and labeled in this one, and it's both 90 because the scale factor or the angles don't change. So no matter what the scale factor is, no matter how big or small it's dilated, the scale factor of the angles, or the factor that the angle changes, is not going to be impacted. So that's just going to be 1 because they'll stay the same. So you can think of 90 degrees in that larger circle divided by 90 degrees in that smaller circle equals a change in factor of 1. The radius, so the radius is a length measure. So the radius is going to be impacted by K. So that's just going to be equal to 3 times. It's going to be equal to the scale factor. The length of the arc, okay, again, this is a length measurement. So again, it's going to be impacted the same amount as the scale factor is. So the length of the arc is going to be 3 times bigger. And then the ratio of the circumference to the diameter. So the circumference, the ratio, meaning divide. So if we take the circumference divided by the diameter, that's always going to give us pi. And that comes from the circumference formula of pi times diameter. If we just divide both sides by d, every time you do the circumference divided by the diameter, it's going to give you pi, no matter how big or how small the circle is. So the ratio of the circle's circumference to its diameter is pi. And if we were going to take a look at this, we could also kind of look at this as if we thought about doing the circumference divided by the radius. Because if we did circumference, the other circumference formula is 2 times pi times the radius. So what if we did circumference divided by the radius instead of just by the diameter? So circumference divided by radius is always going to give us 2 pi, no matter what the size of the circle is. So circumference by diameter, pi, circumference by radius, 2 pi. All right, so extending this, go ahead and look at these 3 questions. See if you know the answers from this activity to see if you understood the basics of that activity, and then come back to the video. All right, so what if we drew a tiny circle? Okay, so if this was our original circle and we made it smaller, and we made a tiny circle that still had a central angle of 90 in that 90-degree sector. Is it a dilation of the original? Why or why not? And yes, because it's still 1/4 of the circle, right? So it's because it's 1/4 of a circle, so it stays the same proportion, and we know that all circles are dilations of each other. So if it's still taking up the same portion of the overall circle, then we will be good. Suppose we dilated a circle not by a scale factor of 3. So let's take a look at this, and instead of the scale factor being 3, what if the scale factor was 1,000,000? Okay, so what if we multiplied this by 1,000,000 times bigger? What would happen to the radius? So the radius is still a length, so the radius would be multiplied by 1,000,000. So would the arc length, because it's just a length. So that arc length would be 1,000,000 times bigger. The central angle would stay the same. So in this case, it would still be 90 degrees. Okay, because angles don't change in a dilation. Lengths change by a factor of K, or the scale factor. And then what would the ratio of this enormous circle's circumference be to its diameter? So if we did the ratio of the circumference to the diameter, what would that ratio be? Again, that's going to be pi. So what would it be if we did it divided by the radius? So circumference divided by radius is 2 pi. All right, then in 10.3, if you're doing this in class, you'll have some cards to sort. Your teacher will give you some cards to sort. If you are doing it at home, I'm going to enlarge these cards in just a second here so you can pause the screen and see them and do it yourself. But what we're going to do is take and try and sort these cards into categories and then explain your categories. So do it a few different times, like 3 times, split them into categories, whatever you want. Just be able to, just know that you're going to need to explain it, be able to describe it. So I'm just going to enlarge this so people who don't have cards can get them. All right, hopefully you can see those a little bit better. You can pause the screen and then try and sort those. All right, now that you've sorted a few different cards and come up with some different categories, let's take a look at one of the categories you might have come up with. Again, you came up with quite a few different categories. I'm just going to focus on one in this video. So let's take a look at card E. So card E said 270 degrees. And immediately I'm noticing this arc right here comes from a 270 degree angle. I know that because I know that 270 is 3/4 of 360. You also could know that by seeing that this is 90 and 360 minus 90 gave you 270. But so I'm certainly going to put these two cards together. Okay, one other thing I noticed was that this card just says 45 degrees. And then this arc right here, this angle looks like it's half of a right angle. So here would be like a 90 degree angle, and that angle looks like it's half of it. So this one seems to be a 45 degree central angle here. So I'm going to put these two cards together. And then we were just talking about arc length versus circumference versus diameter. And in this case, they gave us arc length versus radius. So I remember from our discussion before that we talked about that the circumference divided by the radius is always equal to 2 pi. And in a previous lesson, we talked about that arc length divided by radius will help us kind of with that those are proportional ideas if the central angle is the same. So let's take a look at doing arc length divided by radius. So in this case, arc length is 4 pi divided by the radius is 16. So 4 over 16 simplifies to 1/4 pi. And you know, these are central angles here. So I'm kind of wanting to think about, is 45 degrees the same as 1/4 of pi with this measurement? And so this 2 pi is my whole, my circumference divided by the radius. So if I compare that to this 0.25 pi, I find out, and if I can simplify this, that this is 0.25 or a quarter goes into $2 8 times. So this is 1/8. And 1/8 of a circle, 1/8 of 360 is 45. So this one right here also has a 45 degree central angle, or it's 1/8 of the whole circle. And when you're thinking about kind of relating that to here, this is the whole circumference divided by the ratio. So if we kind of thought of that as maybe halfway, so this is the whole circle. If we thought about it just as halfway, okay, half of 2 pi is pi, and this 45 is 1/4 of that pi, which means it's 1/8 if we went all the way around. And that's giving us that 45 degree angle. So just a few different ways to think about that. And so if I look at This next one, this one has 15 pi divided by 10. So this one, 15 over 10 simplifies to 3/2 pi. And so that's certainly not a 45-degree angle because we have 1.5 pi instead of 0.25 pi. Well, 1.5 is very similar to this 270 if we think of this as 1, 2, 3, 4 total halves to get all the way around. This is 3 of those halves, 1, 2, 3. So this one has a 270-degree central angle. And again, you could look at it by doing this, 1.5 pi divided by 2, okay, and 1.5 divided by 2 pi, sorry, and 1.5 divided by 2 is 0.75 or 3/4 of the way around the circle. And 3/4 and 270, central angle, the same. So then this next one, we have 12 pi over 8. This one, again, 12 over 8 simplifies to 3 pi over 2. Well, we already know 3 pi over 2 gives us a 270-degree angle, central angle. So this is 270 as well. And then if we take a look at card H, we've got 6 pi over 24. And 6 over 24 simplifies to 1/4 pi. And a fourth of, if your ratio is 1/4 of pi, then that comes from the same central angle as a 45-degree central angle. So those are just maybe a way that you connected these cards, and one of the categories that you used. Could have done different ones and could have figured out kind of the central angle a different way. This is just one of the ways to figure out that central angle. So did you actually calculate the central angle and the ratio of the arc length to radius for any of the cards like I did? Maybe you did, maybe you didn't. And I'm just going to put the word angle in here. So what observations did you have about the results? So when we did calculate those, we found that, you know, the ones that had the same ratio, 1/4 pi, or if we wanted to call that 0.25 pi, all came from the same central angle of 45 degrees because they were each 1/8 of the overall circle. And the ones that simplified to 3 pi over 2, or if you wanted to look at that as a decimal, was 1.5 pi, all ended up being 3/4 of the circle, or a 270-degree central angle. So suppose I gave you another card that had an arc length of 30 pi units and a radius of 20. Without actually doing a calculation, what central angle do you think it's going to go with? And so since we've got kind of this number in front of the pi is bigger than the radius, it's likely that it's going to go with this one. Since here we had the arc length larger than the radius, gave us more than halfway around the circle. Okay, gave us to 270. And maybe in your head, and it just said don't calculate, but maybe in your head you know that 30 over 20 simplifies to 3 over 2, which then again gets you here. All right, so suppose a circle has a radius of 8 units and an arc length of 2. What ratio of the arc length, what's the ratio of the arc length to the radius? Okay, so arc length, it said an arc of 2 pi, a radius of 8. So the ratio of the arc length to the radius is going to be pi over 4, or 1/4 pi. So if you think of this as a 1 up here. So based on the work you did in the card sort, what might the measure of this central angle be? So we recognize that as a 45-degree central angle. And could we verify this with another method? So they certainly gave us the radius here, so we're able to calculate the entire circumference. So the circumference of this would be 16 pi. And then our arc length that they gave us was 2 pi. So let's compare 2 pi to the entire circumference to see what portion of the total circle we have. And so we see that those pi's cancel out, and 2 over 16 equals 1/8. And 1/8 of an entire circle, which is 360. So 1/8 of 360 is 45 degrees. So taking a look at this table, we've got an angle name here, and then they give us the circle radius and the arc length without actually calculating. Can you put these in order without actually calculating the central angle measure? Can you put these in order from smallest to biggest angle? So when we're looking at this 5 pi over 10, right? So looking at this ratio, 5 pi over 10 would be pi over 2. 2 pi over 12. So 2 pi over 12 is going to be pi over 6. And 30 pi over 20 is going to give us 3 pi over 2. And if we think about what we just kind of looked at, is that a circle, so pi over 4 was a 90-degree angle. Let me just get a circle drawn here. So we kind of looked at this pi over 4 was a 45-degree angle. Sorry, pi over 4. Pi kind of gave us halfway around the circle. This one was pi over 4. And then all the way around the circle, we kind of thought of as a ratio of 2 pi when we look at circumference divided by radius. So looking at how big these are, this has a fraction of 1/2, this is 1/6, and this is 3/2. So this would be the smallest way around, okay? This would be the largest because this is over 1. So this is the biggest fraction of them. And then this would be in the middle of those. All right, so lesson 10 summary, we found out that we can use the relationship between the arc length and the circle's radius to get some information about the size of the central angle. So we know that if we divide the arc by the radius and they're the same, so if we do 3 pi divided by 9, that simplifies to pi over 3. And here, if we do 5 pi over 15, that simplifies to pi over 3. So then we know that these central angles are the same since the ratios of the arc length to the radius were the same. And then that's what they put in this second paragraph. So comparing arc length to central angle helps you to determine the central angle and compare the size. So go ahead and try this cool down using the information that you learned today. And if you are struggling or need more help with it, make sure you reach out to your teacher.